in this video, we're going to write the equation of a tangent line to the graph y equal x squared minus 3 at 0.36. Well, I'm going to go ahead and show you. Let's just go ahead and draw this graph. We know it's a parabola, right? And it's a parabola that's going to go down 1, 2, 3 here. And actually, when x equals 1, then we're going to get -2. X equals -1, we're going to get -2. Then we got to go up 1, 2, 3, 4, and we'll get x equal to 2, y equal 1, so 2 squared is 4. When I plug 3 in there, 3 squared is 9 minus 3 is 6, so 1, 2, 3, 4, 5, 6, 3, 6. So here's the graph of the function they're asking us to graph. All right, and they're saying we want to know the tangent line, the equation of the tangent line at this point right here, the point that comes and just touches that graph right there one time. All right, well, we've already talked about that the slope of that tangent line is going to be its derivative at that point. So we got to find the derivative. And once we find the derivative, we'll have its slope and we'll have its point. So what do you suppose we think we need to use? Point slope form. So that's where we're going. We're going to step 1, find derivative. And step 2 is we're going to use point slope form. Okay, to write our equation. Okay, so it sounds complicated, but it's only 2 steps. Maybe you'll find the derivative is complicated right now, but I promise you'll get very good at it, and it won't be this complicated. We know that to find the derivative means that we need to do f of x plus h minus f of x divided by h, right? So we're going to go ahead and we're going to go ahead and replace all our x's with x plus h because that's the first thing it tells us to do. So we're going to have x plus h cubed minus 3. Or sorry, not cubed, squared. Wow, sorry, squared. It's squared up here. Minus then x squared minus 3. And that's all over h. And one thing I forgot to write on there, and my calculus teacher in college used to yell at me for this one. Limit as x approaches, or as h approaches 0. I gotta remember how to write the limit as h approaches 0 for every step. So again, now we're going to, again, if we plug 0 in, it would be an undefined function. So we don't know what its limit is right now. We have to do some simplifying first. So this is saying take x plus h, square it. All right, so x plus h squared is h squared, x squared, you square the first term, multiply these two terms and then double it. That's a shortcut way of foiling this thing out. Multiply these two and double it, so I get plus 2xh, and then square the last term, so plus h squared, and then minus 3. All right, so I have all this taken care of. Now I'm going to distribute my negative sign because that's what this is telling me to do. So I'm distributing my negatives to minus x squared plus 3. And again, this is all over h. And to keep my calculus teacher in mind and happy, limit as h approaches 0. All right, and like I said, the beauty about using the definition of derivative is that these terms over here will always cancel something out for us. So if you look, I have an x squared here and a negative x squared here. Those guys cancel out. I have a minus 3 and a plus 3 over here. These guys cancel out. And all I'm left over now is with a 2x plus h. So I have the limit as h approaches infinity, or sorry, h approaches 0 of 2x h plus h squared all over h. And again, we talked about this last time. Since every term has an h, we can do one of two things. We can pull an h out and say we have h times 2x plus h, because if I distributed that again, I would have 2xh plus h squared divided by h, right? That's the same thing as what I have over here. Or I can realize that every single term has an h, and since every single term has an h, I can divide this h out of everything. You can't just do it with just one of them. It's a pet peeve of mine when students do that, when they divide it by just one of them and say, hey, that guy's gone, and leave these terms over here. You can't do it. It has to be every single term, and that's the same thing we're doing in this next step. I'm just showing you why. Because this is multiplication, now we can cancel these guys out because it's multiplication. All right? So we're left over now with the limit as h approaches 0 of 2x plus h. And now finally, since we don't have anything on the denominator, if we plug in 0, we're not going to get an undefined function. Finally, we can plug this thing in and plug 0 in for h. This is 0. So now our limit is just 2x. So our derivative of this function is just 2x. So that gives us an equation for any point we want to know. We want to know the slope of any point on a line. Here's our equation. Well, we just want to know the slope of this graph when it's at 3. X equal to 3. So when I plug 3 into here, I'm going to get my function. And actually, I never showed you the symbol in the last graph. This f prime of x means the derivative. All right. So f prime of x means the derivative. Our derivative equals 2x. So f prime of x, so f prime of 3, so when x equals 3 is 6. So our slope at x equal to 3 is 6. All right? So we know our slope. We check mark on finding the derivative, found it. Now we have our slope, which is 6 at that point, and we have a point. Therefore, we use point slope form to write the equation of the tangent line. All right? So our point slope form is y minus the y value of our point equals our slope, which is 6, times x minus the x value of our point. And we'll just go ahead and simplify and get into point slope form. So 6x minus 18 equals y minus 6. Add 6 over to the other side, I get y equals 6x minus 12. And that there is the slope of our tangent line. And if you remember what our graph looked like, it did have a positive slope. Our tangent line was going like this at the beginning. It did have a positive slope. And so that is the equation of our tangent line right there. I hope this helps, and we'll see you in class.